Hey friends, my name is Chris Noring. I am a senior advocate with Microsoft. In today's stream, we'll talk about how to build generative AI applications using OpenAI and .NET. So if you're here to learn something about AI applications, .NET and C Sharp in combination, you are in for a treat. Now, first off, let's talk about today's agenda. There are a few different topics, few different headers that I thought I would cover throughout these 30 plus minutes. Let's see how many minutes we actually use. Feel free to put any comments or questions in the chat. Now, first off, let's talk about why we have generative AI. I'm sure all of you have noticed that in the year of 2023, there were a lot of changes happening in the area of artificial intelligence. So let's try to ground ourselves. Let's add some context. There's also this new topic on the horizon called prompt engineering. And prompts are as simple as a natural language sentence, but there is a few tricks associated with it to make sure that you are succeeding in the best way possible. The third thing on our agenda today is to talk about different types of application, because you will learn how to build a text application, an image application, a chat application, and search application. Those are a bit different from each other, but don't worry, I'll give you the context so you understand how are these apps different, how can I leverage those to my benefit. And then we'll cover a few best practices around how you are economical in your spending and some other best practices that is good to know about. And by that time, will be ready to sum things up so you know what is the takeaway from today's talk, what's next, Chris. So yeah, let's get started. First off, why generative AI? Well, for one thing, right? We've all gotten used to in the last few decades to using a mouse for input and a keyboard for input. But the thing is, generative AI is coming with something new, a universal interface. So what does that mean for you? It means that you can use your own language skills. If you're taught in English or Swedish or Albanian, it doesn't really matter. The AI will understand you. So there's no longer a notion of you needing to be an expert on SQL or C Sharp. It doesn't really matter, right? So as I said, it speaks your language. You are able to have a natural conversation as an end user with that system. Now, there's also the notion of it taking away a lot of that heavy lifting, all of that boring work that you do as a developer, or maybe just working somewhere else than, development. You could be writing a report, or maybe you're trying to create the next recruiting ad and hopefully you will land a few candidates. AI is coming to everybody on the company, and this is a golden time to be an application developer because you're able to build those apps that will make everyone's lives better. And it will also make you faster. You will be able to find things in second. I bet a lot of you are spending time today reading books or maybe going to Google or Bing just to find that information that you need. And it takes you time, right? It takes time because you need to learn how to search these systems. You don't really know what you're searching for, or maybe you're answering a colleague. That instant response isn't really there today without a lot of research. And this is what the AI also offers. It offers this one point that you can converse with. So summarizing important info on both video and text, that's a given today. I don't know if you all are using Microsoft Teams, but if you look at a Teams meeting today with a video, you already get that AI insight, what this video is about. You get a summary and you understand what the next steps is without even watching the video. That is a fantastic feat, right? Because many of us are sitting there on Zoom or Teams or what have you today in a lot of meetings, and we just wish that someone or something could summarize all that important information for us. So think of AI as getting you 90% of the way there. And there are other benefits. It gives you insights. So what does that mean? It means that if you're working with reports today, or maybe you're sitting as part of a board and you just want that insight into your business, what's going well, what is not going well, and what should I do about it? With AI, you're able to produce business insights in seconds using, for example, Power BI. And if you're a developer, the good news here is that you can easily get insight on your code. If you got issues on your code, either it's bugs or maybe there are security issues, all of that insights makes you better and it makes your life easier because you have that co-pilot, that buddy. So yes, this is definitely a future to look forward to if you're a developer or if you're working anywhere in a business. So prompt engineering. So what is that? Well, first off, if we talk about prompts, prompts are nothing weird or special. They're just text. That's the way that you would say hello to someone, or you say, can you tell me about this and that topic? Conversation. Now, prompt engineering means that there's a skill associated with how you ask these questions. Just like when you ask a teacher or you ask a professional, trying to fix your car, there's a way to ask about certain topics to make sure that you get the answer that you need. So prompt engineering is really a skill in how to converse. So imagine this. Imagine that you have the following example that you are trying to ask a question. Using prompt engineering just means that it's nice to add a question mark to a question, or maybe you're asking someone about a image of a car. Adding enough context about what car that is from what year is just about being nice towards the AI so it produces the results that you want. And then there's another example of don't only state the what but the how. So imagine that you wanted to produce a piece of code or maybe a report. Just saying that you want this and that code might not be enough, but you might actually have specific requirements. You might say, hey, I want you to use this and that library. I want you to code in this and that style, or maybe I want a report that is written in 400 words. Being specific on the how can also greatly help you have success. And then there's a matter of a few core principles. And this is the best thing you can do, honestly, after this talk is go to Wikipedia, search for prompt engineering, because they will go through a few different tricks that you need to learn about. One is called few shot prompting. This is you creating a prompt, a very simple prompt. Chain of thought prompting is another technique that you could be using. And the idea with chain of thought is that you teach the AI how you want them to go about to solve the problem. So imagine today that you're a tutor, right? And you're trying to tutor a student, make sure that they solve this math problem. So what do? You don't just tell them what the answer is, but you're trying to tell them about the steps how to get there. You're saying that to solve an equation, you first need to understand what's important part in this question, take out the important part, and then do the first calculation, the second calculation, the third calculation, and in the fourth step, you're actually presenting the results. That's what chain of thought prompting is about. It's about breaking it down into steps to the AI, showing it similar examples, and you will arrive with an outcome that you appreciate more. And then there are various mitigation techniques to make sure that can you actually trust the response coming back from AI? If you use least to most prompting or meiotic prompting, you're able to question various parts of the outcome and say, oh, you're really sure about this answer? What about this answer? What about this part of the answer? So remember that AI will do its best to answer you, and sometimes it even makes stuff up, which is called hallucinating. So make sure that you're using the right techniques to produce the response you need, and make sure to question the AI. Don't take it at face value. Now, that's a bit of a grounding theory. Now we're setting a context of what is generative AI, what is prompt engineering, why do I need to care? There's another part of this stream that I'm sure many of you have tuned in for. So hello. Please let me know what parts of the world you're coming from. I'd love to learn more about that. So when it comes to building AI applications, there are a few different choices at our disposal. Now, I'm sure most of you have used ChatGPT. That's a text generation app, right? You construct a prompt and you get some kind of answer back. But then you also have another very similar version of doing this, which is images. I'm sure some of you have used tools like Midjourney or DALL-E, and you type the text prompt again, and you're able to get out some kind of appealing image that you can use in your system, or maybe you're just producing that image for gags. The other type that I wanted to go through today, so you can see how that works, is a chat. Because guess what? You don't have to start fresh every time that you talk to an AI. You can actually say, hey, you and me, AI, we had a conversation before, and guess what? you were conversing with me like you were Abe Lincoln, or you were conversing with me like you were the president of France. Being nice to the AI by grounding it in context and saying who you are, but also reminding it that you had a previous conversation, is what makes out a chat application. So here you're, for example, able to say that, hey, you are a helpful assistant. And now that you know that you are an assistant, now please answer this text prompt that I'm sending to you. And the last type of application that we will look at today is called a search application. I bet many of you have seen examples already how AI LLMs are able to use your company data or maybe some other data that you're interested, maybe a movie database, and you're able to search through that body of information. And using your natural language prompts, you're able to get responses on your company or maybe the interest that you're interested in, maybe the most popular movie of 1997. So I will also show you the grounding theory and how you can get started with building search apps. So let's start with our first type of application, namely called a text application. And there's a few different use cases for why we would have that in the first place, right? I mean, if you're only playing around with ChatGPT, it's kind of good to know that, hey, you know what, there's actually a business use case here. And classification, for example, could be a very interesting use case. So imagine this. Imagine that you get a query. Maybe this comes as an email to you where it says, here's a bunch of emails and they're containing a lot of different information, and you just don't have the time to read through all those thousands of emails, but you want to sort them into different buckets so that you know whether this email is about a pricing query, if it's about hardware support, maybe it's about software support. So notice here inside of our prompt how we use this square bracket. So the square bracket means that now we're telling the LLM that this piece of information is important. We're saying that pricing, hardware support, and software support are important through the use of a square bracket. And then we're saying, now I'm going to give you a piece of text coming from an email, and I want you to sort this. So we're saying, here's the following text. Hello, one of the keys on my laptop keyboard broke recently, and I need a replacement. And then you want the LLM now, based on the categories that you feed it to it, what category is this? And the answer coming back is hardware support. So here you're just using the natural capabilities of the LLM because it has been trained on corpus of many, many terabytes. So it already is able to do this. All you needed to do was to bring your skill of prompt engineering into this and just make the LLM aware that, hey, there are 3 different categories. It is one of the 3. Please help me. Please make my life easier by sorting these emails into the correct bucket. Now, another use case that you could be using for text generation apps is how to name products. And I know I'm not super good at naming things, right? But there's a science to it, I guess. I mean, I'm sure there's going to be some marketing team, but imagine that you could build an application that helps with this. What are the components that you need? Well, for one, you need a product description. You need to be able to describe the product, for example, to say that it's a milkshake maker, but it also helps if there are a few keywords that you really think should be part of the name, like it's fast, it's healthy, and it's compact. And then you might want to do this at scale, right? So you just want to repeat this information n number of times for each and every product that you wanted to suggest a name for. So if you look here in red below, you see that based on the first product description and its keywords, it's able to say, well, Chris, I think a good product name here could be Adapta shoes. And for the other product description that you gave me, I think Omnifitters would be an awesome name. And if you look at the third example, it's able to say, well, Fitting Flex and Perfect Fit, that could also be some good names for those pair of shoes that you gave me as the third input. So you see already, if you run a company that maybe you're Adidas, maybe you're Nike, and you try to come up with a few names of sports products or nutrition products, you have a helper right there just by the correct prompt. Now, let's talk a bit more about code, because hopefully a lot of you joining this are software developers. So you want to say, hey, Chris, tell me about the code. Tell me what I need to know as a developer to actually start building these examples. And maybe you got some idea already in your head that, hey, I want to use LLMs to build this and that. So what are the steps that you need to know about? Well, for one, you need to learn how to construct a prompt. I've shown you a few different ideas for text prompts. So here we're saying something simple like, I want you to complete the following sentence. Once upon a time, there was a something something. And the business use case here is maybe not a great one, but it's maybe for those of you who are a parent and you want to tell a story to your son or daughter, or maybe you got a niece or nephew and you want to have them to have a new story each and every night as you tell them their bedtime story. Now, the next step as part of this is to ask the LLM. And here we're using the OpenAI library. So what we're doing is to feed it the engine information and the prompt, and we're getting some kind of textual response back like so. As you saw, there wasn't much to it, right? Constructing the prompt, make sure that we have an OpenAI client instantiated through an endpoint and a key, just as you see in the sentence above. Make sure that then you have the prompt, make sure that you do the ask to this endpoint, and make sure that you print the answer and do what you want with it, right? So I'm doing this on the back end. So for this to be shown to the end user, you'd probably want to put some kind of web UI at the top and display this nicely in maybe a text box, right? But just 1, 2, 3. Just remember those simple steps. And let's see a demo how this actually would work out. So I don't know if you've seen our GitHub repo, but we actually created a repo with 12 different lessons in it. You will see links at the end of this presentation, but it's called Generative AI for Beginners. And this is actually taken from one of the lessons where you are taught how to build a recipe generator, because we all know how hard it is to figure out what to eat for lunch, what to eat for dinner, and how do we make sure that those recipes don't include ingredients that we, for some reason, might be allergic to? So let's kick off this demo so you can see how things work. What I'm using here is something called Polyglot.net Interactive. And this is the .NET team's response to Jupyter Notebooks. You are able to run .NET code, JavaScript, and Python, PowerShell. A lot of different languages are supported. And the idea is that you have these text cells containing code, or you can have text cells containing Markdown. And what you can see here is how you have a play button. And the play button, if we push that, that means you're going to run that particular piece of code. Before we kick off this video here, you can see how we are constructing this prompt. So, and we can just change this text to whatever we want. We also see how we here are kicking off a call to get completions async. So we will get some kind of response back from a web endpoint, and then we are printing the response. So let's kick this off. So first off, we have the prompt. And then next off, we want to do the actual call. So we are kicking this off, and now we see some kind of result. And we see that the result is there was a small town in the middle of nowhere. So that could be an acceptable response. And I, for one, if I was telling this story to someone, I would want to know a bit more, right? So I might want to say, hey, actually give me a response that is 300 words long to make sure that it's a story. But as you can see, we get different responses for every call. And why is that? Well, when you call an LLM, right, you need to know that it's not determined what the answer is going to be, but you can control the process somewhat. And you do that through a variable called temperature. A temperature is an expression for how random it should be. If it's close to 0, that value between 0 and 1, it means there is no randomness to this. If it's closer to 1, that means that the answer is completely random. So, and this is the reason why the response is so varied that the default value of temperature is 0.7, meaning it is very random. Now, if we keep watching this video a little bit, you see that for every time I'm trying to do this, you see that it generates a new story. So if you're that uncle or aunt watching this and you want to tell this story to your children or nieces and nephews, you will be able to make them happy with a brand new story every night. Now, this second example here that I'm venturing about in is about recipes, right? And this is really useful for you if you try to figure out what to cook. And what you need to know about this specific lesson is that it asks you for ingredients that you have at home already, because we all know, we might have a leek or an onion or maybe a piece of potato, and you just try to scratch your head and wondering, what can I actually do with these few ingredients, and what happens if I have a few more ingredients, what then? And you might also want to express to this recipe generator that, look, you, under any circumstances, you cannot include peanuts, or you cannot include gluten, or whatever allergy you have. So it's important to include some kind of filter as part of your prompt. Now, because this is user input, right? I've already given it a static value of chocolate because I like chocolate. And I've also said, like, hey, peanuts, that is my kryptonite. Definitely don't include peanuts into anything here. So if we run this, we're able to see that we get a bunch of recipes. And if we look here, you see how we can also send in an options object. And this is where I'm talking about. This is where you can really configure how many tokens you're using. And tokens is an expression for how big the response is going to be. And temperature is something that we also can change to our liking to make sure that as I said before, the answer is completely random or not so much random. So now at the current value of 0.9, that means that the value is going to be very, very random, which is great if we want to cook and we like variety, right? So the more random, the more varied courses you will eat for dinner or for lunch or for whenever you use this recipe generator. So if we run this, we can see how it generates a recipe for us. And here we can say that, okay, here comes sugar cocoa, and it seems to be the recipe for a chocolate cake. Fair enough. Chocolate cake sounds really good. And it's also giving us some instructions. So what else? We might want to run this again now. And this time around, we are getting what? Chocolate fondue, chocolate peanut butter cups. As you can see, the recipe is very different from what we had before. So hopefully you all saw now how we could be using text generation apps to build interesting text generation use cases. Now, moving forward, talking about image generation apps, they are very similar to that of text. They are both using a text prompt as user input, but the output is different. The output is instead an image instead of a piece of text. And you can see here how we, just like before, starts with a client that's being instantiated. We then see how we move on to specifying a prompt. So here we're saying a happy monkey eating a banana in watercolor. We're also defining some kind of image size, and we can shift that to fit. We can definitely make it 1024 pixels by 1024 if we wanted to, but the output here is a URL, which means that if we actually want this image as part of our desktop or part of our client's mobile application, we need to download the image first, or we need to display this URL as part of a web program. So instantiate the client, define what you want the prompt to be, and then grab that URL that the LLM is responding back with, and then ultimately print out what the URL is. And if we do all that, we will be able to see that generated image. And let me show you exactly how that works by this demo video. So here you see how we have taken this code, and again, we're using Polyglot notebooks. We are setting ourselves up to create the client, to create the prompt, define the size of the image, and also print the image URL. So let's kick this off and see what happens. Right, so again here stating how we have a client, and the client consists of an endpoint and a key. And then we're preparing our call by specifying the prompt and what we want that to be. And let's actually change that into something else. Let's say captain with a parrot on his shoulder. That's quite common image. I can imagine many of you are thinking, okay, Chris, you are trying to generate a pirate. So let's just kick this off and from the LLM. And there we have it. So now we can click this image. And if we do so, we should be able to see what that looks like. Oop, that was a bit fast. Let's try to do that again. And this time take our time showing that. So here you see how we got a man. Definitely looks like a pirate captain, not just a captain, and having a parrot on his shoulder. So you can see how that works for you. Now, you've seen so far text generation apps and image apps and how they were kind of based on the same principle of using a text prompt in. Now we're shifting slightly to that of chat applications, and chat applications are interesting, right? Because we are able to set some context with the LLM, and we are able to say to the LLM, you are this and that person. Like, for example, you are a helpful assistant, or you can just mimic some previous conversation that you had with the LLM. And all of this helps the LLM to actually respond to you back in a better way. So this is a different kind of beast, building chat applications. And some great use cases could, for example, be that you set it into a mode where you tell it you are a spaceship captain and you are thousands of years in the future. And based on that context, you are likely to get a different kind of response once you prompt it and say, what can you tell me about the ship's crew? And you can see here how I'm using different techniques here. One, I'm setting the context for who the system is, a starship captain. Two, I'm saying here are a few different groups of interest for you, engineers, doctors, and crew. And now how you can see how the response coming back says, well, on my starship, I have typically a few engineers, doctors, and crew members. The exact numbers vary depending on type and size of ship, which is a perfectly good response, right? But let's see how that code shifts a little bit. So here you see first how we define this client. And the client consists of an endpoint that we need to call. It also consists of a key, your secret to the application. And you can also see how we are creating a chat completion options object consisting of several messages setting that context. And I just want to call out chat role system, which means now you are instructing the LLM what type of system it is. And the user, this is you prompting. So you can definitely tell it it's a starship captain. And then you, as a user, is now asking your real prompt, your real question, where you say, what task needs doing aboard this starship? And then, of course, you make the chat application call to the LLM, and then you print out the response. And let's go through a demo here so you can see what that looks like as well. And as I said before, we keep using Polyglot because we find that it's a very nice sandbox for our application. If we want to move that into a proper C# project, we can do so as well. But I definitely recommend the notebooks approach if you're just trying things out, as it makes it really easy to reason, really easy to show your colleagues or your customers what you are attempting without building a full-blown project. So here you can see how we are sending in a few different values, but what we want to do is also to demonstrate the impact of having different chat messages and the impact of the output. So we're going to shift from a starship captain, but first let's just call out that we have a system and we have a user and that they're different. And if we want, we can also shift max tokens, and we need to call a specific model to support chat applications, by the way. So let's change this prompt. Let's give the LLM a different context to make things fun. But first off, let's kick off the demo and just say, as a starship captain, I need to be checking the ship system. I need to plan the ship's course. Okay, so it is aware of the context. It understands it is a starship captain. What if it's something else? What if it's the president of France, right? And if you ask it that question instead, you have changed the context, so it's going to answer us differently. So now it says, I need to ensure national security, I need to manage the economy, and I need to improve education. All of that sounds like really reasonable responses now that it changed jobs from being a captain to that of a president. And you can see how we can also be changing the query that we ask it. But what if we change who it is, but also add a little bit more context to the conversation? So as you saw in the completion, we could have said, now you need to talk about the economy, but we are actually telling the president of France that, hey, guess what? You actually resigned from your post. Now with that context, answer me again. So let's just remove that comma. And now let's ask this query anew. Oh, there we go. So let's kick this off and see what happens this time. So now it is completely aware that it has resigned as the president of France, And the immediate task is to ensure a smooth and peaceful transition, and also tie up any loose ends, which seems like a fair response if you're stepping down peacefully, right? So you can see that there are a few things that a president should be doing as soon as they have resigned. So yeah, that's how chat application works. Um, where are we for time? We have been at this for 35 minutes, but let's go into the last type of application I want to show you today. And I'm having this last because it's a bit more complicated, but don't worry, baby steps. I'll teach you all the different things that goes into search so you find confident that you know how to build those. So search, why do we have them? I think that's the first question we need to ask ourselves. Why do I want an app to search? And what do I want it to search? Well, a lot of companies out there is going to find value in searching on their own data. So what that means is that ideally you want to find a situation where you use the intelligence of the LLM because it's been pre-trained on terabytes of data combined with your own company data. And if you can combine the two, you have something really powerful, right? So that means one use case is to have a search application search your own data using the underlying LLM to reason. But maybe there's a third party system that you'd rather talk to instead of your own data, like YouTube, for example, right? You want to be able to search YouTube for that perfect app about Minecraft or whatever topic that you wanted to search. The important part, though, that we need to know when it comes to search, if we're doing this ourselves, is a technique called embedding. So what does embedding means? It means that we will have a vector representation of our text. So we're going to take a piece of text and we're going to turn that into X and Y coordinates. And once we have that vector version, we will be able to compare it to other pieces of text and see if they are related. Now, I want to talk to the guy who actually, or woman, who figured this out, because this is genius, right? This is a concern I don't need to care about the developer. The only thing I, as a developer, need to do at this point is to swallow that this works. So don't worry, just have this in your mental headspace. Chris told me I can take my text, I can turn that into vector representation. Once I have it as vectors, I'm going to compare vectors to understand if my search query is related to whatever text that I want to search. So how does this work? Well, imagine vectors in space, right? X and Y. What we're saying here is that there are a few different ways that you could be going about this. I'm sure some of you have heard about vector databases, but there are also Azure solutions such as Azure Cognitive Search, which makes it simple to store and make stuff queryable for you. So you can definitely do a lot of these things yourselves, picking out the right vector database. That might be a good approach. Or you could be using Azure Cognitive Search, or you can just do very hands-on, create your own embeds and find whatever way to store them, right? I'm just offering you different kind of guidance depending on how much upfront work you are prepared to do. But don't worry about making it enterprise at this point. Let's just focus on the understanding. So OpenAI will help you to create this embedding. So that's just a function call and you get this embedding representation back. And then it's using something called cosine similarity. And if you remember that math that you took in when you were 16 or 17, if you put a value into a cosine function that is close to 0, it becomes 1. And the value 1 means that two pieces of text is very related. And if the value is, on the other hand, 1 instead, and you send that into cosine, it becomes 0, which means that they're not related at all. So look at these 4 different points here in space, A, B, C, and D. So what does cosine similarity mean in this context? Well, it means the distance between the angles. That's what we're saying. So we're not talking about the physical distance between the coordinates, but rather the distance between the angles. So imagine now that the angle between A and B is very, very small. That means that they are actually very related. And you can see how the angle between A and D, on the other hand, is a lot bigger, which means they are less related if you compare two pieces of text. And here's some mathematical things where it says cosine similarity measures the cosine of the angle between the two vectors projected in multidimensional space. That's what you need to know, right? So if we're on the same page here with saying that we are going to compare the angles between two pieces of text, we understand how we can search. Now, the next interesting question is, of course, how do I take a big pieces of text, like a whole page from a book, or maybe a database with a gigabyte of data? Now it becomes interesting, right? Because I want you all to visualize a paper, like a big white A4 paper, or whatever, measurement system that you're using for blank paper that you either write or print. And imagine that you take it physically like this and you start tearing off strips. That's how I want you to think about the process of going from this body of information to small pieces of strips that's going to be searchable. Now, how you do that division is really up to you. So imagine the following. Imagine that you have a book, right? What would make sense from a search aspect? Let's say that you have Lord of the Rings. How would you actually search Lord of the Rings? Well, there are a few different points of interest in such a book. One is, of course, to divide it by chapter or maybe divide it by paragraph. But another thing is to say, well, what if the end user is starting to say that, hey, I want to know everything about Smeagol or Aragon, characters from the book? Or what if I want to know everything that goes down in a certain city as part of the book? So somehow you need to foresee all the different ways that the user could search your source material. You have to do your best and do this division. And once you've done this division, you're able to encode these strips as embeddings. But remember that you have some kind of upfront work of trying to find out how you should slice your information in such a way that you can foresee what the user is going to search and thereby produce the most relevant response to your user. So I've given you an example here with YouTube. So for example, if you want to search a YouTube video, that's a bit more straightforward, right? Because you might have a transcript of a video of different time notations where you say, well, in the first 20 seconds, the user is saying X, and in 1 minute and 30 seconds into the video, they're actually talking about something different. Now, this is one way to slice it, right? But what if you want to search for something else, or in a different way? You might not want to slice it by time strips like this. But let's look at some code how we would go about this. So remember what I said now, that first you need to take a piece of source text, which could be your user query, and then you want to take another comparative text that I'm calling compare to on the left side. And once you have their embedding version, you have their vector version, right? The next thing on the right side is that you want to do some kind of cosine similarity. You want to find the distance between the angles, and you want to find the value between 0 and 1. So what you're doing with the car array is that you turn that into an embedding. You take a vehicle array, and turn that into an embedding. And then lastly, you take the word parrot and turn that into an embedding. Now, once we call the comparer and the score method, we're able to compare, in the first example here, the text car from the text vehicle. And we notice that the similarity between them is 0.91, which is very high, which means that the car and vehicle is related, which is something that we can all agree on. This is the case. However, once we start comparing a car to a parrot, they are not as similar. It's still a fairly high value, but it's nowhere near as similar as that of a car and a vehicle. So now, hopefully, you understand that the higher this value is to 1, the more similar they are. And this is really how your search operation needs to work, right? So what you do as part of a search application is that you first capture the query from the user, and maybe they're typing the word car or the word vehicle or maybe some longer sentence, and then you compare it to the source material, and then you try to do that comparison once you turn the query and the source material into vector representations. Now, I wanted to show you how this works. So we really established that we understand the theory behind all of this. Again, we are going into polyglot.net interactive, our notebook tool. And now you can see here how we start first off with 2 strings, car and vehicle, and then how our next step is to create an embedded version, a vector version of them both. And you can see how we have run this before. And once we run it and print it, we see the values coming out as vectors. We don't really care about vectors. We just need to remember that this is a intermediate step to our path, which is to do a search. And then let's actually kick off this demo. So here you see that we have these two strings. We want to compare a car, the string car to the string vehicle. We need to take that intermediate steps where we turn them both into a vector, and then we need to turn that in itself into a float array, but let's just scroll the code. But first off, I like comments in code, especially when I'm trying to learn stuff. So I just remember, okay, once Chris runs this code, he has the vector version of these strings. Fantastic. What then? He gets a vector representation printed from both the string car and the string vehicle. Okay, good, good. And then we are creating this cosine similarity object. And once we have that, we just need to do one more transformation from the vector embedding response to that of float array. Once we've done that, we're able to then call the score function to actually determine how similar is the text car from the text vehicle. And then finally, we print the score value and say that car and vehicle is similar. It's 0.91, which is very similar, right? And just that we understand how this works, let's introduce a third text, namely that parrot. So, or rather, we're saying a bird, right? So on paper, a bird shouldn't be that similar to a vehicle, and we are kind of trying to prove this by using embedding. So now we are saying, let's create an embedded version of the text a bird. Once we have the embedding version, that's great. But now we also, let's run this piece of code, and this is what we do with code cells, right? We run them, and once we run them, we know that any subsequent cells will have access to these variables. So now we need a float version of this a bird string, which we are storing in the parrot variable. So let's type var. Okay, fantastic. Okay, so now we have three different float arrays that is ready for comparison. And we also need to create this secondary score value now that we know what the score should be then between bird and vehicle. Sorry, are we going to compare car against parrot? So now that we have our second score value, yeah, we forgot something here. We forgot the print, right? So let's borrow that and let's add it here as well. And now let's run it again, and you can see how we are getting two different values. 0.91 is this how similar car array and vehicle is, and they're very similar, right? Remember that the top value here is 1.0. And we also see that the difference between the car and the parrot is 0.79. So if we, for example, have a threshold value where we say we're going to grab all responses back from the database where the similarity between my search query and whatever I found in the database is at least 0.9, that means we're going to rule out responses where, you know, if we are actually searching with a bird as a string, we would then rule out anything that's about cars because they wouldn't be related, right? So it really depends on whether you are comparing a parrot to a car or a car to a vehicle, what kind of value that you're getting. But hopefully by now you understand how this search happens, right? Start with a text, turn that into an embedding, turn that into float array, and now we can compare and just remember that the closer to one the value, the more similar. But you need to figure out what the right threshold value is. Are you saying to return everything that's 0.8 or 0.9? That's entirely up to you. That's something that you need to learn how to configure. And that's the last demo I had as part of this presentation. So now let's talk about something that's really useful to know about, namely tokens. Now, you've seen tokens in the various demos, but I haven't really mentioned them so much. But tokens is really how much it's able to produce in terms of output, right? The bigger the token value, the more output you're going to get. And guess what, though? Tokens is money. You are actually paying for your consumption of tokens. So it's one, it's good to know how tokens are calculated, but two, it's also good to know that, you know, they will cost you money. So have a look at the bottom link here on the right where I say token dash count. This is leading to a page on OpenAI that explains everything about how much you pay for tokens, how tokens are calculated, and so on. So yeah, there is definitely a token process happening on your input where you say, here comes an input. And you can see that there is a correspondence also in 1 token equals 4 characters in English, 100 tokens is 75 words, and so on. So this is information that you want to roughly remember in your head. But there's a but here, and the but it consists of that the number of tokens is language dependent, but it's also model dependent. So depending on what type of model you're using, the number of tokens might be different. So the best thing you can do actually to be economical with your token usage is to write a function that calculates these tokens, and there are plenty of utility functions going around there that can give you a good estimate based on your model, based on your language, based on the size of your input string, how much token are you actually going to use. Now, let's talk about best practices also. I think you saw in the recipe that I was using to generate various chocolate recipes that, I could get different values depending on the value of the temperature. If I had a value close to 0, I would get the chocolate cake recipe each and every time. But if I actually changed it to 0.7 or 0.9, I started getting chocolate muffins and a bunch of other recipes. So depending on your use case, you might want to set the value closer to 1 if you want a lot of random responses, and closer to 0 if you want a deterministic output. Now, as I said before about tokens, knowing roughly how many tokens are going to be used based on your input and based upon the ask of your output, you might want to calculate your token usage because you are paying for the tokens. And also, I didn't show you this as part of the demos, but depending on whether you're using a model for text generation, image generation, chat apps, or search apps, you're actually using different models. So I want to give you that information as a heads up, so you don't get shocked once you start developing your search app and say, hey, Chris, this is not working. And yeah, I'm going to say, well, it's not working because you need to use an embedded version of the LLM to actually call this model. You can't use the same model as you were using when building text generation apps. This information is freely available, though, on OpenAI and Azure OpenAI. So if you start searching and say, hey, guess what? I got a scenario. I want to build a chat application. Then it's going to say, this is the model that you should be using. So don't worry, we have all that information. I'm just planting that information in your head that before you kick off any code, just remember what Chris said. What use case do I have? What model goes with that use case? And try to summarize things. Generative AI is a universal interface, meaning that it speaks your language. It doesn't matter if you say it in Chinese or Hungarian or English, right? It's going to understand what you're saying. So don't worry about learning English on the job if you don't have to. And generative AI takes away the heavy lifting and the boring work, right? Because it can generate docs, it can generate code, and it enables you to find image, and it makes you faster, right? You can summarize emails in seconds, or you're able to find bugs in your code in seconds. And if you're a report person, you're gonna love OpenAI, right? Because it can build you dashboards in seconds as well. And as for AI apps, we went through text apps today, image apps, chat apps, but also search apps. So hopefully you all feel empowered and inspired to build these type of apps. And, I was trying to set you up for success. So hopefully you feel that I did a good job of explaining these basic concepts you need to know to just build those first apps. So please take the leap of faith, start building these apps. And let's see, next steps. My team has worked really, really hard on the GitHub repo. So if you're so inclined and want to learn more than what I'm presenting today, we have a whole repo on GitHub called Generative AI for Beginners. Definitely check it out. There are 12 lessons, and a few of these things that I'm mentioning today is part of that GitHub repo. We got quizzes, we got solutions, and lots of good stuff to learn. Check out the OpenAI tutorial as well. And check out Founders Hub if you're interested in building your next AI startup. Because guess what? We are giving away credits. We are giving away $2,500 worth of credits, $150,000 worth of Azure credits, and we also give you access to an expert network and one-to-one mentoring. So seriously consider if you are in the thoughts of building your next AI startup, and yeah, you want to build a product, it's about AI, definitely go check out Founders Hub. And with that, I'm going to stop sharing my screen and hopefully take some questions. Okay, so since LLM hallucinate, is it practical for business critical customer facing apps? Well, you need to think about it this way. This is a fantastic good question because I've been wondering that myself. I would say this. imagine that you are using LLMs not to get a perfect response, right? You're not asking it for a perfect looking JSON or XML because you're a developer. You need very exact responses. But for conversation type of apps, like imagine that you are selling a certain type of products and you want the customers to actually learn more about your products, or maybe you're selling insurances. It's kind of good to have that chat interface because customers want an improved bot experience. But as when it comes to hallucination, that's not all, of course, right? You can't just say, here's an LLM, do your worst, because you are right, people will hallucinate. So what do you do? There are so what some companies do is that they check out the most common responses to a lot of questions and say, guess what, customers, you can ask this and that prompt, and then you can vet the responses before you actually send them out. So if you're worried about the LLM responses, I actually recommend some kind of human layer. And if you want, you can even use prompts that is able to mitigate the responses to say, does these responses make sense? So definitely refer to my prompt engineering part of this presentation to see how you could be using different techniques to actually verify, is it hallucinating or is this for real? So thank you for that question. That's a really good question. That's so good, but the problem is in every time I request, I get a new pick. Can I get the previous pick or not? Oh, very good question. Yeah, so if you put the temperature close to 0, you will get a very, very similar picture. You will never get exactly the same picture. That's not the point with an LLM. It's non-deterministic. But if you want something that is very, very close to the original picture, just set the temperature value of 0. But yeah, they are not used to be perfect in terms of, like, if you send it 1-to-1, you're not going to get 2, right? You're going to get 1.9, 1.95, 2.1, and so on. So yeah, hopefully that responded well to your question. Do we have any limits on the size of the slice or embeddings? Yes, there are limits, and they are a bit vendor specific. So you need to check that embedding rule because yes, so what happens with embeddings is that they are divided up into chunks, right? So once you do embeddings, which means that it might be part of a sentence, for example, if it's a book, right? So that chunk that it's going to produce is going to be part of that sentence, and you just need to check the documentation how big that chunk is. But depending on what you're trying to do with your text, you might want to present it differently. If not just feed the database or sorry, the LLM a book from A to Z, but maybe you want to strip it up in different parts first. But know that there are chunk limits. So do we have any more questions? Do you pay for response sizes as well, or only for the request? Yeah, so my understanding is that there is one pricing rule for tokens. And yeah, this is a question I will have to partially owe you the answer because I don't want to speculate too much. I know that there's a correlation between paid tokens and input and output, and I believe the link I sent on that page is going to explain more in detail, but I do have to owe you the answer slightly bit. Let me see if we can communicate that back somehow. When searching, do you have to give external access to the internal data? Is it possible to host internally the search app? External access to the internal data. Yeah, so what a lot of people do to make sure, yeah, no, you don't have to, right? So, I mean, there are different ways of using Azure or whatever cloud provider to make sure that you have private networks, for example, right? You can definitely configure it in such a way that it's possible for these two endpoints are the only one that, for example, the request talking to your LLM is coming from a private network within Azure, right? So now you don't have to give it external access. What is the best way to create a chatbot that uses only private PDF files? Yeah, so PDF file for one, right? One of the first things you need to do, right, is to create a bunch of embeddings, and you do that by chunking up the content in various ways. And I would, so based on the code that I showed you today, you can actually use that type of code and just, take your PDF files, run n number of embeddings, as many embeddings are needed on the entire content of a PDF page, and then go to the next page. But you might also want to strip the content and just say, hey, this content can be asked about in 4 different ways. So depending on what 4 different ways you think the users are going to ask you, you might want to do this embedding process differently. So somehow you need to foresee how the user is going to search your content. But another solution that we also recommend to make this super simple for you is something called Azure Cognitive Search. I would definitely check out our enterprise samples for that. So that's something that we can communicate back to you. But Azure Cognitive Search is going to make it super simple. And if you don't want to involve any code, it's actually possible to just take your instantiated LLM resource and just feed it a bunch of PDF data. So there you can actually go into one of the docs pages and say, hey, all I have in an LLM, here's a bunch of PDF files. Now train based on that data. That's also a way forward, which means that you're using zero code. So if all you have is that very, very simple case of PDF files, you can definitely just say, here's my LLM instantiation, here's my PDF files, boom, go. Now learn all about my content. And then the content is actually being trained on that. And then you can just talk directly to the LLM and ask it stuff. So if it's that simple, you can use the simplified version of doing this. So any more questions? Could you please talk a little bit of integrating function calls? Yeah, so function calls are a very interesting part of LLMs, right? Because how that works is that you are trying to detect the intention of the LLM. So what you do with a function call is essentially that you set up a function prototype. So you're saying, here's my function, here's what it's supposed to do, and here's how I want the response to be. So the idea is that you kind of help the LLM by saying, I want the I want you to pair part of the initial user prompt. I want you to yank out certain important part of that initial user prompt and put that as part of the function. So some of these things that the user is mentioning becomes parameter values, right? And then of course the LLM needs to understand that it needs to call a certain function, right? So one, you need to trust the LLM that it will call that function, but also make sure that it's able to yank out certain pieces of that information and knows how to pair that as part of the function call. So that's really part of that action is how that function call would work. So the first step is understanding what part of the user query that is important. Those part of the user query becomes parameter as part of your function. So as part of your function call, you need to instruct the LLM how actually to set up that prototype, saying, okay, if it says something like this, do your best to pair these parameter inside of the function call, and then the function call is being kicked off. And the function at the end of the day is just a web API endpoint, right, that you have created. Or it's a function within, for example, Python or C# that is going to call. But yeah, you need to help the LLM on its way to say, this part of the user intention is important. And if that happens, then yank out that pieces of information and pair that to parameters as part of that function call. There's an excellent docs page on how to do this as well. And I definitely urge you to check out the OpenAI as well as .NET OpenAI cookbooks. We have a few examples of function calls. I need to send you links to that, but we do have some excellent links there. Can you brief on how to run open source LLM on local machines and prompt it, or give some good link to refer to such knowledge? Well, there are actually quite a few different LLMs out there that is just open source. Many of them are, I think, using C++, and you can just run them. And you would use some kind of make command to build and run towards those. And Llama, for example, I believe Llama is accessible just via GitHub. So I mean, what I would say is that there are so many out there. I mentioned Llama as one of them, but there are a lot of pocket LLMs, right, that are vastly smaller than the ones we use on Azure. But of course, if all you want to do is experiment, definitely use those. But if you're trying to run a business, I'm not sure it's going to be a good idea to run LLMs that is running local, right? Because you won't have the same kind of service level guarantees when you do that. But if what you want to do is in the light of, hey, I want to experiment, Chris, I want to learn about this and that, about LLMs, I don't want to pay a bunch of tokens, I would definitely go check out Llama on GitHub. I know that's by Facebook, but last time I checked, Microsoft has a stake in there, so that should be fine to mention on this stream. But yeah, definitely check out GitHub, because there are a lot of free to use LLMs, but be prepared that you might need to learn a few C++ to be able to use them. But I believe most of these models come with some kind of example instructions of how to run them. But what you need to also remember is that if you want this consumable by an end user, you should put some kind of web front end at the top right. So either build a web API or maybe build some kind of UI. But yeah, check out GitHub, check out, for example, Llama, and make sure that you know how to do C++, because that's how I see that most of these models are. And I believe there's a French model also, LLM, that I forget the name of right now. How much to pay for using OpenAI service? Can you talk about the pricing? Yeah, if I remember correctly, and don't quote me on this, I think there's like $0.05 per n number of tokens. So what you're paying for is mostly about token usage. I can't remember right now if there's different standard tiers. I'm sure we have a standard tier and enterprise tier, but you are paying for usage. Good to know though, if you're a student watching this, you can use something like Azure for Student, and then you can ask for access, and you will have a few $100s worth of free credits. If you're also considering using and joining Founders Hub, our incubator, you will be given a lot of credits, $150,000 for Azure that you can use for Azure OpenAI and also for OpenAI. So that will take you very, very far in terms of experimenting. So I would actually try to do that if I'm thinking about building my own enterprise. But you asked me very detailed about what's the pricing image like. I would say it is hinging on tokens, and it's part of $1 for quite a few tokens. I would definitely check out the pricing page for the latest information on that. All right, do we have any more questions coming? Cool. Awesome. Thanks so much, everyone, for watching. I don't know if this is still airing, but I want to definitely check back on the stream if you're interested in building LLM apps. I'm going through 4 different apps as part of this stream, so definitely check back. I believe it's being streamed on YouTube also, I think. So check back to various sections and definitely check out our quick start. And we have a few enterprise samples that's using Azure Cognitive Service as well. So if you want to have an easy path forward to build LLM applications based on your own data, that's highly recommended.